Good morning, everybody. We have seen already the one of the important part of the GATE training program in last lecture. Now we have to be seen the another part of your GATE training program, that is oscillator. We have to be cover that program. In that case, question on that program we have to be discussed. Not only for GATE, but all other question also for the exam that we have to be discussed with respect to your oscillator. Now see, basically oscillator, what do you mean by oscillator, why it is used, what are their application, that we have to be discussed, right? See, oscillator indicate that it is the device which should generate the sine wave without applying any input. That is the basic definition of your oscillator, right? So see, when we have required output, right, in that case we must have to be apply the input for that purposes, because no, if we are not applying any input, it does not provide the output, because this is the thing for any of the application, right? But oscillator is the circuit which we doesn't apply any input, but it also it should be generate some of the output, right? In that case, the effect of the feedback is used in that configuration, right? This is the thing of the oscillator. So oscillator is the basically sine wave generator, because in this case basic output of your oscillator is a sine wave signal, right? See, that's why oscillator is also called as sine wave generator. What we have to be seen in this slide, that is a describe the basic concept of oscillator. Now see, I already told you related to the oscillator. Oscillator is the device we should discuss. Oscillator is the device we should give the performance related things with respect to the sine wave signal generation without applying any input. This is nothing but an oscillator. Then discuss the basic principle of operation of oscillator. Now how the different type of oscillator and how they have to be operated, that we have to be discussed. So normally basically two types of the oscillator, one is RC oscillator, other is LC oscillator. Means the component used for the construction of your oscillator and the operating frequency and the whatever the output frequency coming with respect to your oscillator. Accordingly, there are basically two type of the oscillator, that is RC and LC. Now the question asked on the same topic is that for the generation of the high frequency, which type of the oscillator used? For the generation of low frequency, which type of the oscillator used? See, RC oscillator used for the purpose of low frequency generation, for the purpose of sine wave signal, right? And the for high frequency generation, we have to use the LC oscillator, right? So RC and LC, these are the two configuration of your oscillator. RC oscillator used for small frequency generation, and LC oscillator used for larger amount of frequency generation, right? We just taking the example of the radio signal, right? Radio signal generation, it is nothing but a high frequency signal. For that it is nothing but a radio frequency, right? So radio frequency generation, we have to use the LC type of the oscillator. Another function of LC type of oscillator is tuning. You know, tuning means what? See, when you have to be operate the radio receiver, there are two knobs. One is volume changing and other is tuning, right? Fine tuning knob, right? Fine tuning indicate what? Particular frequency of the particular station. If we have to be adjust only that time, that station should be running, right? So in that case, we have to be use the LC oscillator. LC indicate that two component. L is nothing but inductor, C is called as capacitor. So inductor and capacitor configuration used for the generation of high frequency signal, and RC indicate that resistance and capacitor. These are the element used for the generation of low frequency signal, which is required for the different application. So for that purposes we have to use the oscillator. Okay, analyze the operation of RC and LC oscillator, means according to the performance, according to their frequency, how and why that particular RC or LC used, and whatever their effect in case of your RC and LC, that we have to be discussed. See, RC our analysis of the RC oscillator is that RC oscillator uses a small frequency generation which should be up to the 10 kilohertz, right? Up to the 10 kilohertz frequency generation, we have to use the RC oscillator. Greater than 10 kilohertz, it is also called as a radio frequency signal. We have to use the LC type of the oscillator. Then describe the operation of the basic relaxation oscillator circuit. Now see, relaxation oscillator means what? That we have to discuss. Relaxation indicate that it should be generated the sum of the signal, right? Means either it is a sine wave or the square wave or the triangle wave in the form of relaxation, means continuously generation of the particular signal. That's why it is called as a relaxation oscillator. Normally sine wave, triangle wave and square wave, that are the also other. See, oscillator indicate that basically it generates the sine wave, but see other wave also, means either your triangular wave or the square wave, that also the particularly small period of the sine wave, right? They are also called as sine wave, because when we have to be discussed, sine wave indicate that it have positive and negative cycles. Same thing with respect to either your triangular wave or the square wave, right? So that is also called as sine wave because it is the mixing of small sine wave. See, we just see the introduction of the oscillator, right? So oscillator means what, why it does or what it does, that we have to be seen. Normally oscillator is the electronic circuit, right? Electronic circuit means this for the generation of the signal, means output signal, we have to be need of the particular component, that is R, C, L, C. According to need, we have to be use the RC component or LC component. RC indicate that resistance and capacitor, LC indicate that inductor and the capacitor. These are used for the purpose of the generation of the particular type of the frequency. Okay, normally whatever the signal applied across here, in case of your oscillator, we doesn't apply any input signal, right? So see, for any of the devices, if we have to be apply the input, in that case we have got the output, right? But oscillator is the device which we doesn't have apply any, doesn't apply any input. It also it generate the sum of the output, right? So oscillator is the device which doesn't apply any external input. It also generate the sum of the output. Basically see, internally for the operation, see how it work. I'm telling you, input signal indicate that any of the signal that should be applied as input for the this configuration is a 0. So how it generate the output? See, when we have to use the one of the power supply for the generation of the particular device or working of the device, means what, if we have to be considered as a oscillator, right? So for that oscillator working, we have required the some DC power supply, right? Some DC. See, no one device in the world are operating without applying any power, right? So if you have any example, the device which should be operated without power, please tell me. Example, the device which should be operated without applying any power. Please tell me if you have any known device related to the working on without applying any power. Tell me, please tell me. Did you know any device which should be operating without applying any input other than oscillator? Because we have just discussed the it should be operated without applying the input. Tell me, or input indicate that power. See, there is not any device which should be operating without power. Here also, see, with respect to oscillator, it should not, means without applying any input, it should be operated, but without applying power, it is not possible for with respect to your oscillator, because its operation we need the power, that is a DC power, right? We have applied the DC power internally. Whatever the DC power applied for the configuration, it is basically converted as a random signal. See, random signal indicate that it doesn't have any shape, right? So that see, in case of this configuration, we have to use the positive feedback, means some part of output is again applied to the input. This is the basic thing with respect to the oscillator. Initially, if we have applying the input, I'm tell you detail of it in next session. But see, in this case, we doesn't apply any input, indicate that DC signal, the output of operation of means for the operation of your configuration, that is oscillator, we have applied the sum of the DC signal, right? So that DC signal, see, that DC signal produces some of the random signal. Random signal indicate that it doesn't have any shape, right? The feedback of that output, that is a random signal, is again applied to the input, because basically oscillator is the positive feedback devices. So some part of output is again applied to the input. It is a positive feedback. So that due to that positive feedback, whatever the random signal is again and again applied to the output to the input, output to the input. So it should be again and applied. Due to that, after all, small time indicate that in a microsecond there should be a formation of the sine wave. This will be happen in case of your oscillator. Okay, now see, in this case, oscillator are the circuit that produces the continuous signal of some type without the need of an input, right? I'm telling you, we doesn't apply any input yet, also generate the output. The reason where it is, we have applied the DC signal for the operation of your oscillator, and due to that DC signal for the operation of your devices, there should be formation of some random signal, right? That random signal is again and again applied to the input, right? So due to that, after all small time, it is in a few microseconds, there should be generation of the sine wave. This should be happen without applying any input. It should be produces output as an sine wave. This is the thing, right? These signals serve a variety of purposes, right? No, so why we need of this, whatever the output of your oscillator. See, in case of your local oscillator indicate that for the purpose of reduced signal. Reduced signal indicate that actually if you have to be considered as a if you have particular radio station, right? In a radio station, high frequency signal plus phase signal that should be added and transmitted over long distance, right? For that purposes, that high frequency signal, see, for that high frequency signal, we need of the oscillator, right? So see, in case of radio signal, what we have to do, there should be sine wave. Sine wave signal means our phase wave signal is also called as sine wave that have low frequency. If that signal is traveling over the long distance, it is not as like as, means it should be changes. That's why what we have to do, the concept of superimposition. See, superimposition usually in case of your radio signal, right? In that case, what they have to do, the whatever the audio signal that should be added with your high frequency signal, that is superimposing, means low frequency signal and high frequency signal that are containing each other. This is nothing but a superimposing principle. So due to that superimposition, that signal traveling long distance, and that does not changes with respect to time, right? So that's why this high frequency signal generation is the work of your oscillator, right? That oscillator signal plus whatever the voice signal that should be added with each other, and then it should be traveling, right? So for that purposes, we have to use the oscillator. Okay, now see, communication system design. We know that there are large amount of development in today's world of the digital today's world of the communication system. See, all over world there should be development only happen due to the, there should be tremendous development in the digital world, right? So see, in case of communication, you know that in the 1990, near about 2000, in the 2000 in that period, there should be 2000 period, there should be 1G in the, I just telling related to the mobile communication. I'm just telling you related to the mobile communication. In that period, for the incoming call, see, for the incoming call, there should be 2.99 paise required for that incoming calls, right? So after all development in the technology, that then formation of 2G, 3G, 4G, now upcoming is 5G technology, right? So technology improve the whatever the, this is not only used for the voice communication, it also today's world it used for the data communication, right? And development of speed that also happen. So this will be happen only development of the communication, right? For that purpose, communication, how it is used, I'm telling you. See, you have seen the tower of the particular that is a BSNL, then Jio, they have towers, right? For that tower, what they have to do, there is a one of the center means, see, I just tell you one of the example how the call should be happen. This should be related. That's why, and how it is used. See, your mobile, right? You have to dial the certain number. On that number dialing, you have to connect your nearest part of your MTSO. MTSO indicate that mobile telephone switching offices, right? See, your calls means when you have to calling the another person, in that case your call attaches to the mobile telephone switching office, right? Mobile telephone switching office of the particular, consider you have to use the net of Jio, right? So you have to connect it to the MTSO of the Jio, right? So connecting that part means your signal connecting to the MTSO, there should be user of the high frequency signal, right? In that case, you have to be use the oscillator. Okay, after all that signal, see, MTSO signal should travel, means should detect the location of the wherever you call, right? Accordingly, that call connected by your MTSO. That's why call, if you have to be nearest part, means two friends that should be connected near, and if they are call each other, there should be requirement of the minimum 5 to 6 seconds minimum. Greater than that time also required. This is happen only due to the your call connected initially to the MTSO, means mobile telephone switching application, then that should be connected to your pen, right? So see, for that connection purposes, they have required the high frequency signal, and that high frequency should be generated by this uh, oscillator. Okay. Uh, then digital system indicate that now see, you know that each and every mobile switching office means tower have its own capacity, near about at a time only one tower. If we have to be taking the example of one tower, that tower should be handled at a time only 200 signal. 200 signal indicate that 200 mobile only, right? So greater than that of, if you have to be added, in that case call is not connected. This will be happen in a busy period. You know about the busy period. Busy period indicate that during the period of the 6 to the 8 or 9, in that period, in the city area, there should not be, means there should be problem to connect the call, right? This will be happen because of the each and every tower or cell have its capacity. Okay, so for that purposes means connecting your call, we have to use the digital system now. Now in case of your mobile telephony, means call, whatever the call initiated, whatever the call connected, in that case switching, for the switching digital system used, for that purposes required the different oscillator frequency. For that purposes we have to use the oscillator. Then test equipment make use of oscillator. See, different test equipment. See, if you have to be testing, see, these are all part related to the communication. See, sometimes what happen, if the call related to your network is not connected, in that case whatever the network engineer, they have to be check the quality of the whatever the signal coming. So for that checking of the quality, we have to be use the oscillator. Okay, means oscillator is the thing that should be used all over application of the world for the their high frequency. Okay. Now see, oscillation and oscillator means what? See, oscillation indicate that repeatedly the signal which should be repeatedly, means consider as we have taking the example of the sine wave, right? Sine wave indicate that it have positive half cycle, then again negative half cycle, then again positive half cycle, then again negative half cycle. So oscillation indicate that there should be repetition of the particular thing, either your positive half cycle or negative half cycle, and that should be regularly, right? So oscillation indicate that there should be regularly change in the positive thing or negative thing or anything that should be frequently changes, but it should be regularly. That is nothing but an oscillator, right? The example of oscillatory signal now, sine wave, square wave, triangular wave, right? These are the example of oscillation signal. Okay, oscillator indicate that now see, we have requirement require the different signal, right? Different signal indicate that either your low frequency signal or high frequency signal, right? For the generation of that particular signal, we have to use the oscillator device, right? So oscillator device indicate that it is the circuit which should be produced as the oscillation. Oscillation indicate that it should be changes regularly. Means if we have taken the example of the sine wave, it must be increases in a positive cycle, decreases to the negative cycle, and that should be repeatedly regular only. See, we just take consider as an oscillator only. It should be repeatedly happen, and the same thing will be repeated. Means positive cycle coming, then negative, positive, then negative. Means regularly it should be changes. This is nothing but a oscillator. Okay, we have seen the characteristic of the oscillator. Normally, wave shape, frequency, amplitude, distortion, stability. We just discussed the thing related to the characteristic of the particular oscillator. Wave shape indicate that. See, I'm already told you oscillator is the devices which should be generated the sine wave signal, right? Sine wave signal indicate that not only the sine wave, right? See, sine wave is not only the sinusoidal waveform, but because in case of your square wave or the triangle wave, that also happen in a regular interval of time. Means positive cycle as well as negative cycle, that should be coming with respect to the either your triangular waveform or the square waveform. So the waveform which should be repeatedly changes, that waveform is also called as sine waveform, right? So see, for that purposes, wave shape of the your oscillator signal, that be sine wave, square wave, triangular wave, or any of the wave, that should be repeatedly happen, right? Then we have discussed the frequency. There are basically two types of the frequency of the oscillator. One is RC oscillator, and other is LC oscillator. See, the required frequency for the your application is less. In that, we have to use the RC oscillator. If the required frequency, such as your radio frequency used for the DT, example of DTH, direct to home. Currently, there should be tremendous development in the DTH. Okay, DTH communication, we have to be use the LC type of the oscillator, and then this is also used for the radio frequency. See, just a related part is coming. That's why I'm told you related to the DTH. See, there are so many DTH, right? So many DTH in the India, right? So how the particular DTH for your is identified the particular network? Tell me. For that purposes, what they have to be given the unique code for particular DTH, and how according to their recharge or other things they have to be connecting with respect to your signal, right? Signal. See, your DTH is always connected to the port portion, that is a satellite link. You know that DTH indicate that direct to home. For that purposes, particular, see, if you have to use the DTH of your Dish TV, the location of that different. If you have to use the DTH of Videocon, the location of the particular DTH also different. Why it is? Because see, for that purposes, they have to use the different satellite. Means they have to use the different satellite. You know about the satellite? What do you mean by satellite? You know? Please tell me. You know about the satellite? Suraj Dutta, did you know about the satellite? See, base in a Marathi, that is also called as Krutrim Upagraha, right? Krutrim Upagraha. So what we have to do in case of DTH? See, whatever the particular signal for your either your television signal or the all other signal, that should be connecting for your television. For that purposes, if you have to be recharged, in that case, your signal should be connected to the particular satellite, and accordingly you have to be see that particular program. Okay, means for that connection, the require the frequency is more, because in case of satellite there should be large in a gigahertz frequency required. So for that gigahertz frequency generation, we have to use the internally. See, there should be, when you have to use the DTH, one of the panel LNB, that panel that should be connected with respect to your DTH, that is called as LNB, low noise bandwidth session, right? That should be, it is as like as antenna, and that that should be connected to the internally television. For that purpose is one of the box, right? That is called a receiver box, right? So for that purposes, whatever the radio frequency signal coming from your satellite, that should be converted by your receiver, and then it should be applied to the television, right? So for that purpose of the DTH, we have to be use the oscillator frequency. Then amplitude, for the according to your strength for the particular satellite, it means with respect to television signal, amplitude of the particular signal should be changed. Distortion indicate that noise. See, when any of the signal that should be traveled with respect to your nature, in that case noise should be added with respect to it. But today's world, there should be user of the digital signal. So digital signal, there should be many things that should be added with respect to your signal. That's why chances of noise is less with respect to digital signal. Stability indicate that in a older period, there, if you have to be use the cable, right? You have to be use the cable antenna television, that is cable TV. In that case, if you have to be use the cable, there should be fluctuation happen. Today's world, cable also doesn't have more fluctuation, only wire is cutted only that time of the fluctuation. So this will be happen due to the instability of that particular wire used for that configuration. So for that traveling of the frequency, means whatever the high frequency signal that should be travel over the particular wire, right? So for that purpose, means stabilization of the particular signal, we have to use the oscillation. In older period to today's period, there should not be need of the stabilization, because whatever the signal coming, that should be digital. Okay. See, what are the application of the oscillator? Now see, application of oscillator indicate that I am already told you, whatever the frequency generated by your oscillator, there are two types according to their, they have to be used normally RC oscillator and LC oscillator. That are the two types of the oscillator, right? So RC oscillator used for low frequency generation, LC oscillator used for the high frequency signal. So low frequency signal is called as intermediate frequency signal or IF signal. See, IF signal indicate that intermediate frequency signal. So RC oscillator generate the IF frequency. RF signal generation, there should be use of the LC type of the oscillator. LC type of oscillator, we have to be is the inductor and the capacitor for the generation of radio frequency signal. Okay. So normally this part means particular signal generation or the further reception of your signal, right? For the reception of your signal indicate that if we just taking the example of the DTH signal coming from your DTH, that is high frequency signal, and required signal for your television, that is low. So to convert the particular high frequency signal into low frequency, that should be that also the radio frequency signal, but reducing the quantity of that signal, we have to be use it as an receiver in case of your television signal. User to generate RF carrier in a transmitter. Now see, what do you mean by transmitter? What do you mean by receiver? Just 1 minute I'm telling you. Receiver indicate that whatever the signal coming from, if we have taking the example of Pune station, right? So signal transmitted from Pune station, we have to be received. Received indicate that we have the radio, right? So radio indicate that it is a receiver, right? Means the high frequency signal traveling over there, that should be coming towards the radio, and that radio should convert that high frequency signal into the audio signal, right? So radio signal into audio signal, that is the part of the receiver, right? So in case of here, for the generation of the high frequency signal, means high frequency signal indicate the radio frequency signal. So radio frequency signal, when it should be generated in case of transmitter, consider as a Pune station. So your audio signal, any of the program is nothing but it is the audio signal. If audio signal does not travel the long distance, so that's why that audio signal should be mixed with high frequency signal, and then it transmitted indicate that your audio signal is superimposed. Audio signal superimposed indicate that added with high frequency signal. So this is the work of the your transmitter, right? Transmitter. So transmitter, what it does, your low frequency signal, that is audio signal, that should be mixed with the high frequency signal, and then it should be transmitted over, right? This is the work of your transmitter. So for that transmitter signal, we have to use the LC type of the oscillator used to generate a clock in digital system. You know about the clock. Did you seen the microcontroller, right? So in microcontroller, there should be one of the crystal oscillator, right? For the operation of your oscillator, there should be, for the operation of your microcontroller, we have to be use the crystal oscillator, right? Crystal oscillator is used for the timing purposes, right? So for the timing purposes, indicate that it is act as a clock, because you know about the timing cycle that should be used in case of your microcontroller signal, right? For the generation of the timing signal or clock signal, we have to be use the RF frequency generator, that is a oscillator in internally. Okay, that type of oscillator is called as crystal oscillator. Okay, one of the reason behind it is crystal oscillator used in a microcontroller. The reason behind it is a stable frequency generator. It does not changes with respect to time. So crystal oscillator used in a clocks in digital systems such as your microcontroller. Just an example of microcontroller used as a sweep generator in TV sets and CRO. See, sometimes what happen, I'm just telling you the things related to the TV. See, you have seen the older period TV, that is size of that particular TV is large. Okay, if you have to be started the TV in sometimes there should be wave, one of the wave that should be traveling from one portion to the other portion, right? And after all, there should be a picture on the screen, right? So this is nothing but a sweep signal. This why that happened, because there should be aging indicate that older, right? Aging of the internal component usually in case of your older TV. In that case, due to that, there should be sometimes required to generate the sweep signal. Sweep signal indicate that the signal which should be passing over the period of the time. After all, it should produce the picture signal, right? So for the generation of the sweep signal, normally today's TV, within a fraction of second, there should be generation of the sweep signal. Sweep signal is used for the generation of the picture which is on your television. Okay, so generation of sweep signal, we have to be use the oscillator. Okay, oscillator. So sweep signal also the part of the high frequency signal. And CRO indicate that cathode ray oscilloscope. Cathode ray oscilloscope indicate that this is the device used for the particular seeing of the either your sine wave, square wave, triangular, or different measuring the signal. That's why we have to use the CRO. CRO used in all of the application for the measuring the input signal, whatever applied across it. Oscillator are the circuit that generate the period signal. We know that periodic signal means positive half cycle or negative half cycle, or the signal which should be changing with respect to the time, and it should be repeatedly periodically. This is the example of the oscillator. See, this is the repetitive ramp signal. Ramp, it is also called as sawtooth signal. Sawtooth indicate that in a Marathi, लाकड कापायची करवत असते ना, this is also called as sawtooth waveform. Okay, so for the generation of sawtooth waveform, we have to be use the oscillator. In the sum of the application, we have to be need of the sawtooth signal. So sawtooth signal, it is also called as ramp signal, ramp type of the signal. That is increasing so up to the some level, then again it is decreases. That type of the is called as sawtooth type of the waveform. It is also another name for it is ramp type of the waveform. So normally we know that oscillator is the devices which should be converted the DC power into the AC power. How it is, I am telling you already, because we doesn't apply any input, but for the operation of the particular devices, we apply the DC signal for that device operation, and that DC signal must be converted into the random signal. Then again, it should be applied again and again, so that lastly that signal should be act as a sine wave. So actually oscillator is the device that should be considered, see, that should be considered as a DC to the AC converter. Okay, so for that DC to the AC conversion, it doesn't need of the any of the input. Why? Because no feedback is used in this case. Feedback indicate that some part, in this case, no input is applied. Input indicate that we doesn't apply any input signal. We have just applying any signal. See, in this case, feedback is needed. That must be required in case of your oscillator. Feedback indicate that some part of output is again applied to the input. It See, feedback have two types, that is positive feedback and negative feedback. See, positive feedback means what? Some part of output is again applied to the input, and another thing, input and output is same phase. What it indicate that there should not be change with respect to your input and output. Okay, this is called as positive feedback. Negative feedback indicate that whatever the input, exactly opposite than that of your output. This is called as negative feedback. See, we know that we have already seen that basic thing with respect to your oscillator, that is a sine wave, right? Sine wave indicate that, see, this is the diagram of sine wave. So positive half cycle, again negative, positive, negative. So basically oscillator is a repetitive signal generator. Repetitive indicate that either your positive is coming, again negative is coming, positive is coming, negative signal is coming with respect to it. And basically it is a DC to AC signal generator, right? So we know that there are basically two type of the feedback. Feedback indicate that some part of output is again applied to the input. Now see, the use of the question asked in case of your GATE exam, I'm telling you related to this part. See, in which type of the feedback is in case of your uh, oscillator, or another question, just I am telling you the answer of that, and again I'm telling other question, right? See, which type of the feedback used in case of your oscillators, right? See, in case of oscillator, for the generation of, see, why the positive feedback is what I'm telling you. See, answer is positive feedback. Why positive feedback is used? See, we know that whatever the output coming from your oscillator, it is a random signal, right? So random signal indicate that if the again and again it applied, again and again it apply, indicate that positive thing, right? Positive feedback, right? So due to that positive feedback, at a last time it should be generated a sine wave, right? So oscillator is the device uh, which should be uses the positive feedback. The reason main it is because if we have to be use the negative feedback indicate that whatever the output coming, that is opposite to the input, in that case we doesn't got the sine wave, right? So in case of your oscillator, we have to be use the positive feedback. Another thing, so where is the negative feedback used? The question asked in again, where is the negative feedback is used? Related question, that's why I'm telling you. See, the negative feedback used in case of your amplifier. I'm already told you in last lecture, negative feedback used in an amplifier. Now see, we just see the whatever the effect of the positive feedback and whatever the effect of negative feedback. See, positive feedback increases the strength of the signal, right? Means whatever the input applied, that should be, see, whatever the first time, see, during the first time output coming is a random signal, means it doesn't have any shape, right? So it should be repeatedly applied to the input, becomes it a sine wave, right? So positive feedback increases the strength of the signal, right? This is the thing, right? Now see, and another thing, positive feedback is in case of your oscillator. Okay, now see, the negative feedback indicate that whatever the input applied opposite to the again apply, means if we have applied the sine wave as an input, consider if we have applied the sine wave as the input, output is coming as a cos wave and it should be again applied. So what happened, due to the negative feedback, there should be reduction in a gain, right? Reduction in a gain. Now see, we just tell related to the amplifier. Amplifier, what it indicate that amplifier is the device which should be used for the purpose of whatever the input apply, that should be increasing, right? So it also, I'm telling you, the whatever the signal coming with respect to your amplifier, that should be more. But right, if we have to be use the positive feedback, it becomes the signal more, right? Means if in case of your amplifier, if we have to be use the positive feedback, whatever the signal strength required, that is more, right? Basic thing. But it is does not use in case of your amplifier. Means basic need of your amplifier, whatever the input applied, that should be enhanced or increased, right? So which is the method for enhancing the particular signal? For that purposes, we have to use the positive feedback, right? But we know that positive feedback increases the strength of the signal, but we doesn't use the positive feedback. I'm telling you why it is not used. The reason behind it is, when we have to use the positive feedback in case of your amplifier, it enhances the signal, but it unstabilizes the signal. Means what happen? The strength of the signal is increasing, but that should be vibrating, right? It should be vibrating. It does not stabilize, right? So if we have to use the positive feedback in case of your amplifier, signal increases but it does not stabilize. This is not acceptable. See, I'm telling you one of the example related to the same. In an older period, if any of the function, if we have to be use the amplifier with a mic, sometimes what happen, signal strength somewhat in an older period. Today's amplifier doesn't have that property because they have desired a different technique, right? In that case, sometimes what happen, the signal strength means sound some increases, some decreases. This will be happen during older period, right? So in that case, there should be use of the positive feedback, right? There should be development in today's one, so they have to be use the negative feedback. So due to the negative feedback, there should be, in case of your amplifier, there should be reduction in the gain of the amplifier, but it should be stabilized, right? It should be stabilized. So for the gain stabilization, in case of your amplifier, we have to be use the negative feedback. And in case of your generation of sine, in case of oscillator, we have to be use the positive feedback. 2 point C, according to this, whatever I am explaining, 2 point that should be important. One is positive feedback is in a oscillator, negative feedback is in a amplifier. Okay. See, we have seen the type of oscillator. Now see, we know that RC and LC, that are the two type of the oscillator. RC oscillator is the oscillator which should be generated small signal, means compared to the LC oscillator. So up to the 10 kilohertz frequency, we have to use the RC type of the oscillator. When the frequency is greater than that of your 10 kilohertz, in that case, means require the, if we have required the a frequency that should be greater than 10 kilohertz, in that case we have to use the LC type of the oscillator. See, RC oscillator have two types, that is Wien bridge oscillator and phase shift oscillator. Now these are the two type of the RC oscillator. LC oscillator have the Hartley oscillator, Colpitts oscillator, and crystal oscillator. Now see, these are the three type with respect to the LC oscillator, and RC oscillator have only two types, that is Wien bridge and the phase shift oscillator. Okay. Then another type of the oscillator, that is a unijunction or relaxation oscillator. These are oscillator used for the continuously changing frequency. This relaxation oscillator used normally. Here you have to note down, RC oscillator used for the low frequency signal generation, LC oscillator used for the high frequency signal. Normally, in case of Hartley oscillator and Colpitts oscillator and crystal, there should be used of the inductive element, LC element. And in case of earlier configuration, that is RC, we have to use the resistance and capacitor element. Okay. See how the oscillator and how the oscillator working. See, basically there should not be, basically I'm telling you, basically there should not be any difference with respect to your oscillator and the amplifier. Only smallest change which should be coming with respect to the oscillator. See, normally this is the block diagram of your linear oscillator, right? Block diagram of your linear oscillator. In that diagram, what we have to see, in that case, this A indicate that amplifier, means whatever the thing with respect to your amplifier, that should be coming with respect to this block. Linear amplifier indicate that we have used the amplifier which should be increases the whatever the input signal applied across it. See, in this configuration, we doesn't apply any input, but part of output, it generated the output signal. Now see, we have seen the output of linear amplifier. See, this is the block of the amplifier. This is beta is called as feedback network, right? Feedback indicate that output part is going to apply to the input. Basically, it is amplifier, it is the feedback network, right? So initially we have to be considered as a, here is not any input is applied across your amplifier, right? So there is not any input is applied. For the operation of this amplifier, we have to be use the one of the DC power supply for that device operation, amplifier operation, right? So due to that DC power supply for the operation of these devices, it should be generated some of the noise signal or some of the random signal, means it doesn't have any shape, right? So some noise signal or random signal is again applied to the feedback network, right? Feedback network indicate that it is the network which should be does the phase shift of this input signal, right? Phase shift of input signal. Now see, in case of oscillator, we know that in a in case of common neutral amplifier, right? You have seen in a second year common neutral amplifier, whatever, see, if we have applied the amplifier have sine wave signal, we got the cos wave. Did you understand? If you understand, in that case you know about the common neutral amplifier. Basically it considered as a common neutral amplifier, means whatever the input applied, that should be exactly opposite in this case, right? So 180-degree phase shift coming with respect to the common neutral amplifier, right? Basically if it is considered as a common neutral amplifier, so whatever the input signal applied, if we have, see, in that case, in case of here is not applying any input, I just telling you the one of the example. If we have applied the sine wave input, we got the cos wave output. Means in case of your amplifier, there should be 180-degree phase shift of the output. Okay, in this case, random signal 180-degree phase shifted, that should be coming across here. And another thing that again apply to the feedback network. See, in case of feedback network, it should be network which should does again 180-degree phase shift of the whatever the signal applied here. So if here is a random signal applied, it should give the 180-degree phase shift. Again, it should be applied to the feedback network. It should again give the phase shift of the 180-degree. So total phase shift is 360-degree, and it should be again applied to the input. Okay. So see, with respect to oscillator, oscillator is the device which should be does two characteristic with respect to this, means block diagram is that feedback means oscillator is the circuit which should be does the phase shift of the 360-degree. How it is? 180 due to the amplifier, feedback network 180 to total 360-degree phase shift which should be coming with respect to the oscillator. There are two conditions with respect to oscillator. One is there should be phase shift of the 360-degree, and feedback factor. This is called as feedback factor. That is, feedback factor must be greater than or equal to 1, right? Means for the generation of the oscillation or for the generation of the RF signal, there are need of the oscillator. For the generation of the oscillator signal, we have to be need of the two oscillatory condition. One is your, there should be phase shift of the first condition. There should be phase shift of the 360-degree, or it is also called as 0-degree. And second thing, there should be feedback network, means whatever the feedback level, that should be greater than or equal to 1, right? Feedback level that should be greater than or equal to 1, right? That are the two conditions for the generation of your oscillator signal. We have seen the other thing in a next session. Before that, we have seen the sum of the question on that topic. See some of the question related to the oscillator, right? An oscillator convert. Normally we have seen the 4 EPT answer has given how it is, right? That we have seen. We have seen that an oscillator convert. power into DC power, right? Power into DC power. It is wrong because it doesn't convert the power into DC power. We already see the PPT, right? In that PPT, what we have to do, oscillator is the device which should be convert the DC power into AC power, right? So first answer is wrong. Power into DC power, that is wrong. Power into AC power, right? We know that power indicate the DC power and it should be converted into the AC power, right? So this is the right answer because we know that when we have to be seen the PPT of the oscillator, in that they have to be written as a oscillator is the device which should be convert the DC power into AC power. So this is the answer. Other answer we have to be also seen mechanical power into AC power. No, it is not mechanical power because we have applied the DC signal for the operation of that particular oscillator, right? For the working of particular configuration. So this is also wrong. Third, none of the above because your answer is power into AC power. That's why only three are the wrong and the these two, that is DC power into AC power, that is the answer. In an LC transistor oscillator, the active devices. Now see, which I'm to give you the diagram of the 1 minute Hartley oscillator. This is the diagram of your Hartley oscillator. Now see, this is the diagram of Hartley oscillator. We've seen how the question asked. See the question. In a LC transistor oscillator, the active devices. Now see what do you mean by active and what do you mean by passive, that I am telling you. Active device indicate that for the device which operation doesn't requirement of the power. We know that if you don't know, I am telling you, diode, transistor, then field effect transistor, BJT, that are the active devices. Passive devices, now I'm telling you, inductor, capacitor, resistor, that are the passive devices. Okay, so question asked here, in a LC transistor oscillator, the active devices is, see the diagram. Here is a use of your resistance inductor that are not active devices. Okay, then this is the resistance, this is a capacitor, this is capacitor, this LC, this is not also active. Here is one of the transistor, right? So we know that transistor is the active devices, right? So your answer is for that question is, in an LC transistor oscillator, the active device is LC tank circuit, biasing circuit, transistor, none of the above. LC tank circuit, nothing, because here is the use of the inductor and capacitor. Okay, biasing circuit, there should be use of the resistance, right? It is not the part. Transistor, we know that transistor is the active device. Okay, none of the was, because your answer is transistor, right? So transistor is the active devices, so your answer is transistor. Did you understand how the answer is transistor? Please reply, give me the reply if you have understand or not understand. I don't know, don't give the response. Nikhil Magar, did you understand why the particular answer? Okay, we have seen the next thing. Okay, thank you. In an LC circuit, when the capacitor is maximum, the inductor energy is. Now see, in a LC circuit, LC indicate that inductor and capacitor. Okay, when the capacity is maximum, capacitor maximum indicate that value of capacitor is maximum, indicate that in a capacitor value in a microfarad, right? So capacitor value in a microfarad, the inductor energies. Now see, if the two devices used in the ELC circuit, that is inductor and capacitor, okay. So if the in this configuration, what they have to tell, in an ELC circuit when the capacity is maximum, the inductor energies. Now see, both element gives the energy, right? So there are two elements, L and C, okay. Any of the device which should be give the more energy, so consider as 100 is the energy, consider as 100 is the energy. Now there are two components, L and C, right? If the L element gives the 90 of the particular energy, and other element have more or less, tell me. Two devices which should be connected, here they have to be tell capacitor have given the maximum, it should be 90, then inductor whatever the component connected, it have less energy. That's why it is nothing but a less related thing we have to be seen here. One is nothing but a minimum, other is maximum is not answer. Halfway between maximum and minimum, it is also not, because more energy is grasped by capacitor, so that's why this is not also none of the above. This is not also here. Less indicate that, 10 indicate that minimum, right? So minimum is the answer for that, okay. Minimum value which should be consumed by this inductor, okay. We stop now, okay. Time is over.